Okay, a homogeneous system is a system that looks like this. The idea here is that the right-hand side, all the numbers in the right-hand side are zero. An important observation for a homogeneous system is that it is never inconsistent. It always has a solution. Let me write that down. And the reason is because the solution x1 equals 0, x2 equals 0, and xn equals 0. That means that the solution that is given by the vector 0, 0, 0, 0, when all the variables are 0, it is a solution of the system. If we replace x1, x2, x3, and all the variables with 0, we get equality in all the equations. This solution is called the trivial solution. And we have that every homogeneous system, it has the trivial solution as a solution. An interesting question is if there are more solutions besides the trivial solution. Let's take a look at this system. It's a homogeneous system. You see zeros here on the right-hand side. And let's see if there are more solutions besides the solution x1 equals 0, x2 equals 0, x3 equals 0, which is called the trivial solution. The augmented matrix, in this case, is the matrix 1, negative 3, 2, 0, negative 3, 8, negative 4, 0, 1, 2, 9, and 0. Let's use this 1 to put 0 here and here. Then I'm going to multiply row 1 by 3 and add it to the second one. The first row, I'm going to keep it the same. And for the second row, I multiply by 3 and add. Multiply by 3 is negative 9 plus 8, negative 1. Multiply by 3 is 6 minus 4 is 2. Here is a 0. And to put a 0 here, we're going to do this row minus this row. Then here I have 0, 5, 7, and 0. Now I'm going to use this number to put a 0 here. And row 1 and row 2, I'm going to keep it the same. And I'm going to multiply row 2 by 5 and add it to the third one. Here we have 0, 0, 5 times 2 is 10. Here we have 17, and then 0. Notice that this system of equations, these three columns, which are the columns that correspond to the variables x1, x2, and x3, they have pivots. That means that all the variables are basic, there are no free variables, and that means that there is a unique solution. Unique solution. But we know that the trivial solution is a solution, and then in this case, the trivial solution is the only solution. Let's see another example. This is a homogeneous system, and before I try to solve the answer if the trivial solution is the only one, I would like to point out that this system can be written in the form A times x equal to the 0 vector, where A is the matrix 1, 3, negative 5, 1, 4, negative 8, and negative 3, negative 7, and 9. And x is the vector x1, x2, and x3. We can write this system like this. Another observation that is going to be important before I answer the question if the trivial solution is the only one is that for every homogeneous system, the solution is the span of some vectors. Let me write that down. Notice that even in the case that we have the trivial solution as the only solution, this statement is true because the vector 0, 0 is the span of the vector 0, 0. Then in every case, if you have a homogeneous system, the solution is the span of some vectors. Let's study this system. In this case, the augmented matrix is the matrix 1, 3, negative 5, 0, 1, 4, negative 8, 0, negative 3, negative 7, 9, and 0. Let's use this one to put 0 here and here. The first row is going to stay the same. For the second row, I'm going to do row 2. I'm going to replace row 2 with row 2 minus row 1. Then we'll get 0, 1, negative 3, 0. For row 3, I'm going to replace row 3 with 3 times row 1 plus row 3. Here I get 0. 3 times 3 is 9, minus 7 is 2. 3 times negative 5, negative 15 plus 9 is negative 6, and then 0. Now I'm going to replace row 3 with negative 2 times row 2 plus row 3. Row 1 is not changing. Row 2 is not changing. And row 3, when I do negative 2 times 1 plus 2 is 0. Same thing here, and we get this. This matrix is in echelon form. Notice that this is a pivot. This is a pivot. And when we look at the columns, this is the column that goes with the variable x1. This is the column that goes with the variable x2. This is the column that goes with the variable x3. We notice that x1 and x2, those columns has pivot. Then we say that x1 and x2 are basic variables. And we have that x3 is a free variable. Notice that we know that the system is consistent, and since it has a free variable, that means that there are infinitely many solutions. Then in this case, the answer is the trivial solution the only one? No, there are infinitely many. Let's try to write the answer of this homogeneous system as the span of some vectors. To do that, let me write the solution. What we need to do first is to rewrite the system according to this reduced echelon form matrix. Then we have x1 plus 3x2 minus 5x3 equals 0. x2 minus 3x3 equals 0. And the other one is 0 equals 0. Then the second task is to write the basic variables in terms of the free variables, and we start with the last equation. x3 is free, then we write x2 is 3 times x3. We are writing the basic variables in terms of the free variables. And now we rewrite the first equation. We have x1 plus 3 times. We want to have only this x1 and the free variables. Then x2 is going to be replaced with 3 times x3 minus 5x3 equals 0. 3 times 3 is 9, minus 5 is 4, and that means that x1 is negative 4 times x3. Then we have the solution of the system. x3 is free, x1 is this, and x2 is this. But now the goal is to write it as linear combination of vectors, and that is also called parametric vector form of the solution. In order to get the parametric vector form of the solution, we write x1, x2, and x3, and we want to have only the free variables on the right. Then x1, instead of x1, we write negative 4x3. x2 is 3 times x3. and x3 is free, you just write x3. Then this can be written as x3 times -4, 3, and 1. This is called the parametric vector form of the solution of this system. And we can see that the solution of this system is the span of the vector -4, 3, and 1. Notice that x3 can be any number, and essentially what we have are linear combinations of this vector. Linear combination of this vector is just what we know as the span of this vector.